All right, let's do this. Hello, everyone. It's September 5th. Just finished the day's work. Man, it's really hard. Really hard. It's like I just depleted my brain, and now I have to try to deplete my brain another time. But I'm not doing it. I'm just, half an hour. We have to stick to the rule, half an hour. If I can do it, I just can't do it. Alright, I have queries. Is of the form LR. Each query defines an array of integers, nums, consisting of elements ranging from L to R, both inclusive. In one operation, you can select two integers, A and B. One operation, you can do two integers, A and B, from the array. Query of integers consisting of elements. So in one operation, you get A and B from this, so 1 and 2, right? 2, 3, 4. Replace them with floor, which I think is also integer. The task is to determine the minimum number of operations required to reduce all elements of the array to 0 for each query. I don't quite understand. So initial is 1, 2. In the first operation, select this and this. So one operation, this 1, 2, 3, 4. Select 2, replace them with this, and then you select another 2, replace another 2. The number of minimum operation required is 2. So 2 divided by 4. Okay, divided by 4. It's like divided by 2 and then divided by 2. Is that the same as move it 2 times? I think it is. Like divide by 2 and divide by 2. Yeah, so bitwise you move to the left, you do right shift 2 times. And in this one, I have 2. 2 is 1. 6 is 1, 1, 0. So to get this to 0, I have to move 2 times. Oh shoot, my bad. It's everybody in between. Holy guacamole. Fuck me. Alright, it's everybody in between. So we have 2, 3, 4, 5, 6. Right. So each operation you can only take 2. Right. So because the right shift, so I say, okay, how about I take these 2? Right, and then they all require. So that's one operation, right? So now for digit, 3 digit. 3 digit require 2, so you take another 2. You will do 5. Huh. Where did this? One operation. No. Each operation is still 2. So these require 2 operations. So I'll do 2 operations and for 5. Yeah. How did you get away with this, huh? Because these require 2 operations. Like you do 1 operation So one operation basically become this. Wait a second. So the first operation turn into this. Second operation. The second operation. So this is first operation. Second operation. Right? Third operation. Fourth operation. In my mind, first operation second operation. Oh, it's because I'm wasting. This one's not paired with anybody else. So you need to pair it with somebody else. How do you pair? Basically, these two can get eliminated with one operation, right? So if you have something like that, so it'll be nicer, right? So we do pair. We pair with this, and then we pair with this. So two operations, I can handle all of them. That's two operation, and this is two operation, because this is no way for you to avoid that. So what I need to do is to find out the minimum number of operations each one need, which I can just do division, right? We can just do division. So number of operation is divided by 4 plus 1. So it's 1, 1, 2, 2, 2. So right, so 1, 2, 2, 2. So basically I have 1, 1, 2, 2, 2. It's the number of operations. And then essentially we're asking, we pick any two and then we do minus 1. We pick any two and then we minus 1. And then the end result is we want to use the minimum number. So because each one you do minus 1, each one do minus 1. So no, each one, the max. So actually we know the maximum, the minimum number, right? Because you have to reduce everybody to 0. So this, if you add them together, it's 8, right? And each time you can minus 2. So the minimum number is 8 divided by 2 is equal to 4. So we cannot do better than 4. 4 is the best. Okay, so 4 is the best. And then we want to know like what's, so like just no waste, right? That's what we want. We don't want any waste. Maybe sorting it is a good way, right? We don't want any waste. And each time you want to minus 2. So if we have the same number, right, the same value, then you group them together, it is not going to waste, right? It is not going to waste. So I'm thinking like if we have, let's say 3, 3, and a 1, right? If you have 3, 3, and a 1, I can do 3 operations. I can do 4 operations for this. Or let's say I don't waste, so I do this first. So 1 operation. Now I have 2, 3. 2 operations. That's 3 operations, 4 operations. So this, yeah, because if you do this, this is optimal. It is absolutely optimal, right? This is optimal because you're not wasting any. So you just want to not waste, which means if you can find some value, some big value, and then some small value, such that a small value adds up to the big value, then there will be no waste. You can handle them. So like in the first question, 1, 2 is essentially 1 on 1. So yeah, that's paired. 2, 4 is 1, 1, 2. Right, it's 1, 1, 2. It's also paired. It's paired because yeah, it's like these two, so it's paired, so it's sum, which is 4 divided by 2. So this is 2 steps, 2 operations, right? It's 2 operations. So what we need to do is to find this type of pairing. Now, the pair. What you might be able to do is find the largest and to see if any of the small can pair with the largest. Just you find the largest, so you get the small, and just start adding until you can't. Right, then you get a new small. I don't know if that's the right approach. I mean, at the end of the day, we want to have as little waste as possible. Yeah, so like the biggest value, you know that it will take that many operations to do, right? It take that many operations to do. And the goal is when we do those operations, we can use the small to supplement it. But if you do the really small one, then you might take away the opportunity for others. So the best will be to find the largest that can pair with it. Then the bigger ones can just destroy themselves. So if you have 2 with the same, yeah, you should do it. So maybe what we need is, the largest or the second largest, and then we find if there's any remnants. Maybe we don't. We do that, largest, second largest, and then we have a new value, right? We put it in, and then the largest, the second largest, put it in, and then we keep going. So basically, every round, we eliminate the 2 biggest values, and then we find its difference. The difference is we're not wasting, right? The difference is not wasting. So the difference is just we put in there, we maybe use it later. So we keep doing this until we may find, until we have like a 0. Like if it's 0, we don't put it in. So this is kind of, again, I don't have exact proof, but it feels right to me. Okay, it feels right to me. No proof. I have no proof. If it doesn't work, then we'll check the answer. All right, I have big caveat. I have no proof of this method. First of all, we find the number of operations to reduce each value. Oh, how many queries do we have? Holy crap. It won't work. It will not work. Because you got this, right? You can have gigantic number in between. How your algorithm will not work. It will not work. Huh. Yeah, because you have to, go through all of them. Like, how do you fancy that to work? Here's the idea. If it's divisible, then we can do optimal. Have you thought about that? Right? So we do know, like if we have a sum, right? We have, A0, A1, AN. Doesn't matter. What we want to know is if it's possible that they can just fit within themselves with no waste. I think as long as the sum, because each time you take 2, right? Each time you take 2. So if the total number is even, then no matter how you take, it will always work, right? It only doesn't work if it's odd. So based on that, it actually worked for all of them, right? So you just need to find if it's even or odd, and then that's the number of operations, right? So it's 2 to 6. If you add them together, is 1, 1, again 2, 2, 2. You add them together is 8. So that will take you 4 operations. So if it's 9, that means you have one that's mismatched. So you have to become 9 divided by 2, right? It will be 5. We can actually test this. If, let's say, 2, 7. Right? I think 2, 7 will be 5. Because you add another one, this becomes 9, so it becomes 5. Exactly. I think that is the solution. But then what we need to solve the next problem is, given a range, how do we find this sum? Like how? Well, we find it by, we know, divide by 4, right? Every value divide by 4. So I know L divided by 4. I know R divided by 4. And it will always go 4 times you increase. 4 times you increase, right? Because if you go from 1, like 1, 2, 3, 0, 1, 2, 3, 4, right? And then 5, 6, 7, and 8. Sorry, so these are 1, these are 2, these are 3. Right? These are 3. So what you need to do is you find this L divided by 4, what value it is, and then you find out how many it needs, and then you only go forward. You can do L mod 4, so you know how many more. Like if you say 4 mod 4 is 0, so you need to add 4. That's the next one. If it's 5, mod 4 is 1. That mod 4. It is 1, but you need to move forward. Doesn't matter. You just need to find the next one that's divisible, right? So 4, you can, this divided by this is whatever, and that plus 1 multiplied by 4, which will be the next one. We just need to find their sum, right? That is the gaming town. We need to find that. So L divided by 4, R divided by 4, okay? R divided by 4. I have these two values. Now I have these two values. If they're different, right? If they're different, by whatever, like if this one is 2, this one is 5, then I know within them we have 3 and 4. Each one will take, so we'll do, in them will be, if I count this as, I don't know, P, okay? So I count L divided by 4 equal to P, R divided by 4 equal to Q. Then what we have here is P plus 1 plus P plus 2 plus plus to Q, which we can do right? How many? It's gonna be Q. Hold on. Actually, no, that's not right. Why don't you just... Yeah, it's just gonna be P plus Q, right? And then P, and then Q minus P minus 1 divided by 2. No, it's plus 1, right? And the whole thing minus P minus Q. This is the things in between, right? So we have this, which I believe can be better. So this is essentially Q plus P times Q minus P plus Q, right? Minus 2P minus 2Q. So this is Q squared minus P squared minus P plus Q. This is P plus Q, right? Q minus P minus 1 divided by 2. Which I think I can derive from here as well, because this is P plus 1 plus Q minus 1, right? And then it's going to be Q minus 1 minus P plus 1. Let's do it again. Q minus 1, P plus 1 plus 1. Yeah, exactly. So this is a sum in between. This is the sum in between. Now, if P and Q are the same, we don't use it. But as long as P and Q are not the same, then we can use it. So yeah, so this is the thing in between, and because each one repeated 4 times, so you are doing time 4. So this thing, or time 4, right? Time 4, which equal to 2 times P plus Q and Q minus P minus 1. All right, so that's that. Now we're gonna handle here, right? We're gonna handle here. What I want to know is, so this is L, right? We have L. We need to know the next one. Next one is P plus 1 times 4. That's the next one, right? That's the next one. So this next one, I don't know how many is in between. So minus L, right? This one minus L. That's it, right? If it's like 2, it's not 2, but it's L, right? L. This is P is L divided by 4. So this, yeah. So this is the number. And then this one will times P. This one times P. That's on this side. And on the other side is going to be Q, not QR, because I need to know how many is in between. So it can be R minus Q minus 1 times 4. So this gives you the one on the left, right? The one, like how many we have on the left, then this one or times Q. Hold a second. This might not be right. No, I don't think this is right. Because if I'm 5, we actually do an experiment, right? 5, I have 20, right? So we say we have 20, 21, 22. How about we're at 22? And then this is for 16. We don't do 16. So this, so it needs to be, it needs to be Q times 4. It needs to be Q times 4. So 4Q, but minus 1. So this will be 20 minus 19. So 22 minus 19 is 3. We have 3. So yeah, so this is on the left hand side, this is on the right hand side, if there's anything in between. If there's nothing in between, just, do that. And then this actually makes more sense. All right, this actually makes more sense. So first of all, we need to find, let's do this. For any query, right? For any query L to R, we find the number of operations needed, right, to make each number 0. To turn each number 0, right? To turn each number 0. This the operation count is L divided by its value divided by 4. Floor, right? Now, since each round we pick 2 numbers, we can take away 2 operations, right? 2 operations, not 2 operations. Yeah, we can take away 2 per operation. The number of, that's not operation, the number of ops. Oh, wait, hold on. We can take 2 operations per round, right? Per round. Now, if the total number of operations in L to R, actually, because it's inclusive, right? I think it says it's inclusive. Yeah. So we do this to make it more explicit, because it's inclusive. If the total number of operations is even, that means we won't waste any round, right? We won't waste any round. Every single round we will handle something. Otherwise, we have to waste 1 additional round. Hence, the problem has been converted to first find the total sum of operations within each LR. let the sum be s, we need to sum up or ceiling s divided by 2. Okay, so now what we need is, we go one by one. So we have a long result. That's fine. And then for const auto queue of queries. Okay, so we say int left is q0, right is q1. I don't like, I have p and q, so this is going to be ge, right? Ge. Ge. Alright, the next thing we need to do is do p. So p is l divided by 4, right? But we need to turn this into static cast. Let's just turn to long and make it much easier to handle all the other things. Okay, so q is static cast long r4. Alright, so we have p and q, we have l and r. So first scenario, if p is equal to q, right? If p is equal to q, there's nothing in between. So what we need to do is find how many is in between and then multiply by this value, right? So what we do is going to be r minus l plus 1, that's the number of count, times p, this is the total number of operations. And what we do is so we can say long s, right? That's the total. And then we need to say rest or plus equal to, is there a way? Yes, we can do plus 1. Because if it's even, let's say 4 divided by 2 is 2. So basically we want 4 divided by 2 is 2 and 5 divided by 2 is 3. But it doesn't work. But if we plus 1, then we can get it. Which means we probably don't need to. You know what? Let's do long here. So both are long. Then we can continue long here. And we don't need a static cast, because this shall be long by default. Yeah, this shall be long by default. So everybody's long. And this essentially we can just go rest plus equal to this plus 1 divided by 2, right? So that's if the same. If they are not the same, okay, p and the q are not the same, and then we have we need to find the sum in the middle, right? S in between. So S in between is going to be this formula. Hold a second. Is this right? P. Yeah, I think this is right. And this is going to be but your times P. Yeah, it's the count times P. Just the count is not 4. So here each count is 4. So we get the count out and times 4. So it should be 2 times, right? So 2 times p plus q times p minus q minus 1 times 2. Get the first one out. So this is the s in between, right? The s in between. And then we need to go s on the left. So s on the left, we'll use this formula, which is p times p plus 1 times 4, which is the next one, minus left. And then long as right, it's going to be q times right minus q times 4, right? Q times 4 minus 1. So this is on the right hand side, 4q minus 1, right, times q. This is on the right hand side. And then rest into plus equal to, no, s between, I can say beat, right, plus s left plus s right plus 1 divided by 2. So that's for everyone. Once we're done, we'll return rest. Alright, if this one can be right, I'll be very, very happy. If it feels right, okay? It feels right. Not sure if it is correct, but it does feel right. And the result is a negative value, which is very funny. Okay? I feel extremely funny. But it's fine. Oh, P and Q, you got it wrong. I need to plus 1. Yeah, I forgot to plus 1. That's fine. Let me try it again. Wait, what? All right, this is stupid. This is very stupid. All right, I am coming. This is stupid, but I still think my way is right. Let's continue. I feel we are on the cusp. I just need to figure out why this thing doesn't work. PQ is both 1, right? PQ is both 1. So it'll be here. That's 2 times 1. 2 plus 3. So the first one is 1. And the second one is 1, 1, 2. Right? 1, 1, 2. So I have 1 and 2. So it's here. We actually try. We have P is 1, Q is 2, L is 2, R is 4. So as in between is 1 plus 2 times, oh, I think it's Q minus P. That's alright. It's alright. Q minus P minus 1. That's 0 times 2 is 0. That's correct because there's nothing in between. So S left is going to be P times P plus 1 times 4. Oh, the P and Q here is different. This has to be minus 1. This has to be Q minus 1. Because P and Q is the operations. Right? P and Q are the operations. These are not operations. You might actually do better by just doing it again to make it more explicit, I think. Although it may be, but let's try it first. Make sure we got it right. Yeah, we got it right. So we can just, remove this. You know what? I am not playing this game. What I'll do, even though this might make us slower, I think it's absolutely necessary Yeah. Are you sure it's L? Are you sure it's not R? Yeah. Yep. All right. Give it a shot. Hopefully it works. It does not. It does not. Okay, 3 and 10. We actually do this, right? 3, 4, 5, 6, 7, 8, 9, 10. Divided by 4. There's 1, 2, 2, 2, 2, 3, 3, 3. So it's 1 plus 8, 9, 18. Right, 18. We'll say 18 divided by 2 should be 9. How is it possible you can get 8? How is it possible you can get 8? You'll take one operation. You'll take two operation. Oh, wait, hold a second. Hold a second. What's each operation? Oh, yeah, each operation you divide by 4. Right? You divide by 4. You do 4 divided by 4. So you do need all these operations. How would you get to 8 rounds, unless we understand the problem wrong. Yeah, you take 2, which means each round you minus 1, right? So you do 2, and that's I don't know. Right? At this point, I have no idea. For example, 8, 10. Okay, 8, 10 I expect to be some value. 4, 7 I expect to be some value. And then we say 4 to 8, 4 to 9, and 4 to 10. We'll try. Alright, so 8 to 10 is already wrong. And many of them are wrong. Okay, 8, 9, 10. That's the first scenario, right? So P and Q is 3. So they are the same. So it's 9 divided by 2 is 5. Huh. That's not right. It's not divided by 2. Wait, hold a second. This requires 3, this requires, so if you select 2 integers, right? You divide by 4, 1 operation. So 1 operation, that's going to be 2 to 10. No, this requires 2 operation. 8 divided by 4. Why do you say it's 3? Because this 3 divided by 4 yeah, that's 1 operation. You take 1 operation, right? So this you need to take 3 operation, 1 operation, but you only take 2 operations. Wait, hold on. How many operations are there? So if it's a 4 divided by 4 is 1. So 4 takes 2 operation, but 5 divided by 4 is 1. So 5 also take 2 operations. 6, 7 take 2 operations. But 8 also take 2 operations. 8 divided by 4. Oh, have mercy on me. Yeah. 8 divided by 4. So is it log? I think it's log. Yeah, divided by 4. I think it's log. It's not this. Oh man. I think I'm still on the right track, but I completely screwed this. It should be log. So we need to do log left divided by log 4. Ugh. And this will be what? It'll be 0. This will be 1, 1, 1, 1, 1, 1, all the way to 16. It's all 1. Alright, because 15 divided by 4 is now 4. It's 3 times 3 point something. Ah, my god. Oh yeah, I got this one wrong. Alright, so I need to freaking rewrite this. The P is the number of operations, right? So this is going to be I actually don't know how to do log with arbitrary base. There gotta be a something. You're kidding me. So it has to be double. Okay. So log L divided by log 4, and then the whole thing static cast or cast to long. Okay. Number of operations plus 1, right? And then we do the same for Q. So it's instead of L, this is going to be R. So I have P and Q, and then I think this is still right. Okay, this is still right. Times P, because there's a number of operations, that's still right. Here is wrong. Okay, this is all wrong. This has to be reworked. And these all have to be this actually no. I think this we can do. We just need to find out. Yeah. We can do this. So basically, this is saying we need to find out what is. So we need to do to the power. So to the power. Power. So std pow. Something to the base of the power. Okay. So essentially, what we need to do here, okay, what we need to do here is to find the next one, right? Next one, and to find the next one, we know the current power. P is already plus 1, right? P is already plus 1. Yeah, like if current is power is 2, then the next is power is 3, which is P, right? Which is P. So we just need to do std pow 4 to the P power, right? 4 to the P power, but then we need to static cast this thing, right? We need to static cast this thing. This is the next minus this, and here Q. right? So we do the same thing here. We say static cast long, and this is going to be std pow 4 to the q minus 1 power. So q minus 1 is actually myself, right? The power. And q minus 1 is going to be the previous one. No, the q minus 1 is going to be myself, and then 4 to the power is going to be at the beginning, and the minus 1 is going to be the previous. So me minus this is going to be the number in between, and they are going to times q. That is right. So we are having only one value left, which is the ones in the middle. So the one in the middle, now it's going to be a little bit more complicated, because we have essentially p plus 1, right? So we have p plus 1 all the way to q minus 1. And each one is, you know, the power, right? So basically we have 4 to the p plus 1 all the way to 4, you know, p plus 2. So yeah, it's 4p plus 2 minus 4p plus 1, right? That is the number of it's not right. It's not right. P and Q are the number of operations. Okay, it's the number of operations. P and Q is the number of operations. The actual one is minus 1. So it's actually from P to Q minus 2, right? From P to Q minus 2. So we have this, we have plus 1, and then the number in between is going to be, oh, but we can loop through because P and Q are not large. P and Q are not large, all right? Because we're doing log, so they're not large. So S in between, we can actually just loop through them, right? Otherwise, like, you have to do this, and you have to do, I don't see a mathematical way, right? So basically, yeah, we start with power of p, so we say 4 to the p plus 1 power minus 1 minus 4 to the p power, right? So this, I'm thinking of p is 2, we have 16, and this is 64. So what I want to know is the number of things in between. So minus 1, actually we're going to have plus 1, right? So basically 63 to 16. So it's like 64. So like, yeah, so this is the number of elements that can use p plus 1, right? So this will times p plus 1. No, this will times p. No, this will times p plus 1. My goodness. It will times p plus 1 because this is the next one, right? This is the next one. And then because the next was the next, so I think we can do this. Right? So essentially here 0 for int I equal to we're gonna go from p, right? I smaller equal to q minus 2 I plus plus. So So 4 to the p is the next number. Is the first number, right? Is the first number with larger operation than L. 4 to the q minus 2 is the first number with smaller operation than q. not a first number with a smaller operation than q. Right, so q is the operation, and then you know what? I think this might make things more complicated than they need to be. You know, I'm gonna change this. P and Q are not operations. So P is exactly the power. Okay, P and Q are the power, and if P and Q are the same, right, then we have this P plus 1. That's the number of operations. P plus 1 is the number of operations. So this is fine. And here, again, left, we're going to go P plus 1, right? And this is going to be 4 to the P plus 1, right? Because P is the power. P plus 1 is the next power. And then 4 to the next power minus this is right. And here Q is the same thing, okay? Q is the same thing. This is the number of operations. You might want to make it even more explicit. Okay, I want to make it more explicit. OP, P plus 1. Right, there's a number of operations for L. Alright, and then OQ, Q plus 1. Right, this is a number of operations for R. So now we can say when P and Q is the same, and this is OP, right? And this is OP as well. But here I will leave it as P plus 1. And this is going to be OQ. And this is going to be the power of R minus, this is actually just Q itself, right? So static cast minus 1, this is fine. Now here, so I need to be P plus 1, this is gonna be Q minus 1, and it makes more sense, right? This one makes more sense because those are the power, and then we need to plus 1 power, minus 1 power, and then we can say this, right? P plus 1 is the first number with larger than, and then this Q minus 1 is the smallest number, and this is also the smallest number with smaller operation than Q, right? Okay, now we can say S bet plus equal to, we use this formula, which is STD. I'm not sure if I need to static cast every single one of them. I think I'm gonna static cast every single one of them, just in case. Alright, so STD, we're gonna put power, so 4 to the, you know, it's gonna be I plus 1 power, because this is the next one, right? So it'll be this minus static cast, long, and this is going to be power 4 to the ith power, which is the current power. So that's the number of elements in between, and all of them, okay, all of them will have the same operation, and that operation is going to be I plus 1, right? That operation is going to be I plus 1. And I'm gonna keep doing this until we hit every single one of them, and we do this. All right, so that's my next solution. We are 1 hour in again. Yeah, the promise was not kept. But it's fine, because I think this one's right. I think this one's right. I'm gonna do one more test case that to verify it. You know what? I also want the original test case. The original test, dude. The original test case. How do I get the original test case? Reset. Okay, and then I put these 8. I think 8 is the most we can do. Yes, this one is right. Most likely. Maybe there are. No, there's nothing. That's it. So this is correct. Well, it's worth it. All right, it's worth it. Performance wise, there's always room for improvement. I have so many I have so many static casts. I probably don't need that many. This part, maybe there is a mathematical formula for this. I don't know, but I feel like there gotta be. Right? I mean, if you look at this, it's just this thing plus the next one, plus the next one, plus the next one. And if you take it out, it's going to be p times 4p plus 1 minus 4p. In fact, this does feel like something that you can simplify, right? What's the next item? It's going to be p plus 2, right? P plus 2. Okay, so we can still do p. So this is p plus 2 minus 4 to the p plus 1. Plus 4 to the p plus 2 minus 4 to the p plus 1. Look. Right? So we can, let's do one more. P plus 3, p plus 1, and p plus 2. 4p plus 3 minus 4p plus 2. So yeah, so this is plus this minus this plus this minus this, right? And then here is the same. We have plus minus plus minus. So what we're gonna get at the end, right? We just need to find out what this value is, right? We should find out what this value is. So it's going to be p 4 to the q. We use our thing. All right, we're gonna start. No. We start with I. Okay. It's just, yeah. This is just gonna I. And this is gonna be p plus. This is gonna be p plus something. It doesn't really matter. So it's just gonna be p, and this is gonna be the last one, right? The last one. But when we do the last one, right? This has to be plus 1. So you can just call it. Let's just call it I to j, right? I to j. So all the p is just going to be I, so to avoid confusion. So it's going to be I for j plus 1 minus 4 to the I, okay, plus 4 j plus 1 minus 4 to the I. I think that's it. And hold on, let me see if I can make this change. Wait. Why? I copy and paste this thing. Oh, I know why. Yeah, it's all right. All right, so we're gonna say, so this is the same solution, but we can replace the loop with a math expression. So what we're gonna replace is p plus 1, that's I, times something minus something plus something minus something, which is the same. We can't just, let's do long diff, right? That's essentially a diff. So we can say static cast long std pow 4 to the what, j plus 1, which is the end as a q minus 1, so it's q minus pow. I is the beginning, which is p plus 1. So this will be times diff, right? This times diff plus diff times diff plus diff. So we'll remove this. Here I forgot the static cost. Not sure. Four. We'll see. Yep, I think it's right. And I think we, yeah, this is gonna be ON, right? This is ON for sure. I think we can improve even more, but we don't. I don't know. I have no clue why. Something. I don't know. Weird. Very, very weird. You can't just like pass 594 test cases and tell me this one is not right. Unless I did count it wrong. Let me think. Let me think one more time. And I think yes, I might have counted. No, it can. How can it be, right? How can it be? let me do it one more time. Okay, let me do it one more time. So we have power. Okay, we do power. I have power from I, so 4 to the I all the way to power to the j. All right. So what we say is 4 to the power I plus 1 minus 4 to the power of I. This gives you the total number that will use I. So we'll do this times I plus 1, right? And then next one is I plus 2. So it's 4I plus 2 minus 4I plus 1. This one times I plus 2, right? And then we keep going up until the last one is 4 to the j plus 1 minus 4 to the whatever. We don't know this one. And this is going to be j plus 1, right? It doesn't matter which one it is, but this is just keep going. And then the way I think we kind of see the issue, I don't think we can just eliminate them. All right, so let's call it I plus n. Okay, I plus n. So this is gonna be I plus n plus 1. Right, let me redo this. This is gonna be I plus n plus 1. I plus n plus 1, and here is I plus n, and this one is gonna be I plus n plus 1. Okay, so if we expand this, all right, if we expand this, we have I times 4 to the, yeah, now these we can delete. This did delete, so all the way is I plus n plus 1 minus 4 to the I. This is good, all right, and then now we have issue. I see where we're going. I plus 1 minus 4 to the I, right, will be plus 2 times I 4I times I plus 2 I plus 1, and then it will be 3. Oh, this is trouble. All right, all the way to n plus 1, right? I plus n plus 1 minus 4 to the I plus n. This is trouble, because when we expand it, it's like it's changing, right? It's changing. So be this minus 2. Oh wait, hold a second. I think there is still hope. Look. We have 4I plus 1 minus 4I, right? Basically, we'll say plus 2, 4I plus 2 minus 4I plus 1. So let's remove the 2. I remove this, so I put a 2 in it. This is 2 times. Right, it's 2 times. And then it's 3 times I plus 3, 3 times 4I plus 2. Right, and then we have n plus 1, 4I plus n plus 1 minus n plus 1, 4I plus n. What you find is this and this, right? This and this. So essentially what we get is minus 4 to the I, minus 4 to the I plus 1, minus 4I plus 2, alright, minus 4I plus 2, minus 4I plus n, plus n plus 1, 4I plus n plus 1. That is what this one is, right? What's next? Next is we can find the sum of this thing. What's the formula? I don't remember the formula. Gordy. Sorry, I have to redo this. So a to the I, and we can just directly plus the 4 to the I plus n, right? And we do 4 times s is 4 to the I plus 1, 4i plus n plus 1. So 4s minus s is 4 to the I plus n plus 1 minus 4 to the I. So s is equal to 3. 4 to the I plus n plus 1 minus 4 to the I. So that's that. So this essentially is n plus 1 times 4 to the I plus n plus 1 minus 3 4i plus n plus 1 minus 4 to the I. That's the one. Okay. So what's I? I is p plus 1. What's n? N is because I plus n is q. So it's q, and then I is p plus I is p plus 1. I is p plus 1. Yeah, I is p plus 1. So it's p plus 1 plus n equal to q. So n is equal to q minus p minus 1. All right, so we put them both in. Hold on. So here, the formula for SBET is n plus 1 times 4 to the power of I plus n plus 1 minus 4 to the power of n I plus n plus 1 minus 4 to the I, the whole thing divided by 3. Yeah. So the formula for this, where I is equal to p plus 1, q is equal to I plus n. I is this, and p plus 1. Hold a second. Q minus 1. Right? Where p plus 1 is equal to I, and then q minus 1 is equal to this. Which means we have I, we have n, right, is equal to q minus 1 minus I. I is p and minus 1. So equal to q minus p minus 2. Right? So with that, we can do it. And let's do a few things first. The power. So long, right? 4 to the power of I plus in 1 shall equal, oh, I cannot start with this, dude. How for to this, right? So that's static long for to the I plus n is q minus 1, right? So I plus n is q minus 1 plus 1, which is q. And then so this is going to be n plus 1. N plus 1 is going to equal to q minus p minus 1. Right? So n plus 1 times pow this minus pow this minus std static cast long std power 4 to the I is p plus 1, so this divided by 3. Not sure, but let's give this one another shot. So first of all, we'll double check on the original. They are correct. We'll use this test case, but I don't think I can use it anymore. So what I'm going to do is I will just screw it. I'll remove everybody, put you here. We run you one more time. Yeah. Well, I guess not. How is it still wrong? Well, a likely possibility is overflow. That's what I can think of, overflow. So yeah, I guess we just use the other one for now at least. But I'll check the solution for sure. But for now, this is probably the best we can do. But like, why would it overflow? That doesn't make any sense, right? That does not make any sense because this is not that big. It's 4 to the q. Right? It's 4 to the q. I don't understand. I mean, we did the math, right? Which is exactly the same as this one. We did the math. I don't know. I don't know. I bet I was wrong along the way, somewhere. Right? It's like this is the same, right? It's the same shit. And just, you know, I must be wrong somewhere. I just didn't realize. This looks right to me. 1, 2, 3, 4, all the way to the last one. Oh, yes, I see the issue. So, yeah, so like these two minus these two minus these two minus these two minus these two minus. So what we have is this minus this minus this minus this minus all the way to this, and then no, that's right. You plus this one, right? You plus this one. Don't know. No idea. No idea why it is wrong. No idea why it is wrong. It doesn't feel like it should be wrong. It doesn't feel like. It does not feel like it should be wrong. Right? I is this, and I plus n, because I plus n is the last one. It should be q minus 1. Yeah, it feels... It looks right. I mean, what the hell? Oh. N plus 1. N is q minus 1 minus I minus 1 minus p minus 1, q minus p minus 2, that's n. So n plus 1 is this thing plus 1 times this minus this minus 4 to the I divided by 3. I don't know. I honestly have no clue why this one is still wrong. I'll call it a day. It's just, you know, it didn't work. Well, we error out much earlier. This might be a good case for us to test, like exactly what happened here. I am motivated. I am very motivated. We'll do this. But this one's much simpler. All right, so two things, okay? So first, I want to figure out why my solution is not right. And then secondly, I need to read the editorial. But for now, let's call it a day. I'll see you guys tomorrow. Adios. Yeah, we did it well.